My name is Flash Isaac, and I'm a teacher from the future. When I was much younger, I saw thousands and thousands of people fail Jamb and unable to gain admission. This made me travel in time. Now I am back with the Flashlearners Jamb app and a series on YouTube tagged 120 Days to Jamb. My mission is to help you blast Jamb and as well get justice for everyone who Jamb has served breakfast. This is episode number 43 of the 120 Days to Jamb Chemistry with Flash Isaac. In this episode, we shall be looking at confirmatory tests. And under confirmatory test, we shall look at tests for cations, tests for anions, and tests for gases. Remember, in the previous episode, we covered preliminary tests, and we agreed that preliminary tests are tests we carry out to know the ions or compounds that are suspected based on appearance, based on the color of flame, and based on the action of heat. How do we confirm these ions? That is where confirmatory test comes to play. Now, Jamb will ask a question like, which of the following does not form precipitate with ammonium, aqueous ammonium? They will give you various options, and you will be wondering, which topic is this one again in chemistry? This is the reason I am taking the pain to cover everything Jamb says, past, present, and even future in this series. At the end of the series, you should be able to score or answer everything correctly in the Jamb hub. And make sure you watch the videos as many times as possible. Now, confirmatory test for cations. Cations are positive ions. Remember, metals generally ionize by electron loss. In the next episode, we shall begin non-metals and their compounds, then metals and their compounds. The difference between metals and non-metals is that non-metals ionize by electron gain, while metals ionize by electron loss. What is ion? Ions are simply atoms that possess electric charge. You see this? This is Al3+. You cannot call this aluminium. Meanwhile, when you have something like this, Al, we can call this aluminium. This is aluminium atom. Anytime an atom loses electron, it will become a positive ion. When an atom gains electron, it will become a negative ion. So generally, metals will readily give out electron. So their ions are positive. This is why we say metals ionize by electron loss. While non-metals generally, example chlorine, oxygen, they will gain electrons to form their own ion. At that case, they become negatively charged. As such, we say non-metals ionize by electron gain. Don't learn to forget, because this knowledge will carry us to metals and non-metals. To test for positive ions, we use sodium hydroxide and dilute ammonia. These are the two materials or the two compounds we use to test for cations. Which of the following are used to test for cations? They are sodium hydroxide and dilute ammonia. This is how we use them. First, you drop them in drops. You put them in drops. Later, you add them in excess. So, sodium hydroxide in drops and in excess, then dilute ammonia in drops and in excess. The ammonia is aqueous. Aqueous means it is in solution, most time in water. So this ammonia is dissolved in water. So aqueous ammonia in drops and aqueous ammonia in excess. Now look at this carefully. When you have an ion which form white precipitate, when you add sodium hydroxide in drops, then when you add sodium hydroxide in excess, you notice that this precipitate is soluble in excess sodium hydroxide, you simply say that lead ion is present, Pb2+. Now, aluminium ion forms white precipitate with drop of sodium hydroxide, and this precipitate is soluble in excess sodium hydroxide. Zinc ion forms white precipitate in sodium hydroxide drops, and in excess sodium hydroxide, this precipitate is soluble. For lead ions, aluminium ion, zinc ion, they give us the same result. They all form white precipitate which is soluble in excess sodium hydroxide. Now, look at this. Cation ion forms white precipitate. However, the precipitate of cation ion is insoluble in excess sodium hydroxide. This is what distinguishes cation ion from lead ion, aluminium ion, and zinc ion. Look at something else. You may be wondering, why is it that lead ion, aluminium ion, and zinc ion are all soluble in excess sodium hydroxide? This is because they are amphoteric. This is a Jamb question. Sodium, zinc ion, aluminium ion, and lead ion are soluble in excess sodium hydroxide. Why? It is because they are amphoteric. Don't ask me what amphoteric means, because this is a series and we've dealt with amphoteric over and over again. Amphoteric oxide, this and that, even in acid, bases, and salts. Now, going down, we have ion 2 and ion 3 ion. When you drop sodium hydroxide in ion 2 ion, you will have a dirty green precipitate. When you drop sodium hydroxide in ion 3 ion, you will get a reddish brown precipitate. Both precipitates are insoluble in excess sodium hydroxide. So both ion 2 and ion 3, they give us insoluble precipitate. Then copper 2+ will give us blue precipitate. This blue is insoluble, while ammonium ion don't form precipitate at all. So you don't really need to cram this. What you should know is that lead, aluminium, and zinc ion, they all form white precipitate and they are soluble because they are amphoteric. Then cation forms white precipitate, but it is insoluble. In fact, apart from lead, aluminium, and zinc, every other ones are insoluble. Then for color, the first four are white, ion 2 dirty green, ion 3 reddish brown, copper 2+ is blue. So these are confirmatory tests for these cat ions. Now let's see test with aqueous ammonia. This is test with sodium hydroxide. With aqueous ammonia in drops, lead will form white precipitate. You see, they are repeating what they did here. Lead, aluminium, and zinc, they will also form white precipitate with aqueous ammonia in drops. But a problem comes in. Only zinc ion will be insoluble. In fact, of all the tests with aqueous ammonia in drops and excess, only zinc ion and copper ion are soluble in excess aqueous ammonia. Why? This is because they form complex ions with ammonia. Why are zinc and copper 2+ soluble in excess aqueous ammonia? This is because they form complex ions. Now, zinc will give us white precipitate, lead will give us white precipitate, aluminium will give us white precipitate. This lead ion and aluminium ion, they both give us white precipitate, and the two precipitates are insoluble in excess aqueous ammonia. So how do we distinguish between lead ion and aluminium ion? We have two ways to distinguish between them. One, lead ion will give us yellow precipitate when you add potassium iodide, but aluminium will not. The same lead will form white precipitate with concentrated hydrochloric acid. However, aluminium will not form precipitate. So this is a test to differentiate these two guys. Cation ion here form white precipitate which is insoluble. But when you test with aqueous ammonia in drops, cation ion will not even form precipitate at all. No precipitate is detected. Then ion 2 will give you dirty green precipitate. Ion 3, reddish brown precipitate. Exactly the same thing you have here. That is what you have here for the color. Even copper ion will also give you blue precipitate. The colors are the same except for cation ion, which does not form precipitate with aqueous ammonia in drops. Then for solubility, they are all insoluble except for zinc ion and copper ion. Ladies and gentlemen, let's look at test for anions, negative ions. Now, when it comes to the test for gases, the test for oxygen and N2O is that or are they rekindle a glowing splint. But the difference is that while oxygen can rekindle a brightly glowing splint and even a splint that is dimming, N2O can only rekindle a brightly glowing splint and it has sweet smell. Meanwhile, oxygen is odorless. The test for hydrogen gas is that it burns with a pale blue flame and it makes a pop sound. The test for ammonia is that it has a pungent smell, while hydrogen sulfide H2S has a rotten egg smell. From here, we shall be looking at test for other gases and test for anions. And like I said, after this, we shall look at confirmatory test, making use of these other compounds mentioned. Now, when it comes to the action of dilute HCl, Jamb will speak grammar, write an essay, and they will ask you which of the following gases is detected or which of the following ion is detected. For example, they will tell you that dilute hydrochloric acid is added to a solid, to a solution, or to an ion, or to whatever. Then, effervescence occurs with the evolution of a colorless, odorless gas which turns lime water milky. You see the keyword, turns lime water milky. So what gas is that, and what ion do you think is present? This is a hot cake Jamb question. Anytime you hear that dilute hydrochloric acid is added to something and you see colorless, odorless gas which turns lime water milky, the gas there is carbon dioxide. Carbon dioxide is the gas which turns lime water milky. Now, for the gas present, it is carbon dioxide. The ions present will be CO3 ion and HCO3 ion. For the gas present, CO2 is detected. For the ions, CO3 2- and HCO3 2- are present. When you hear effervescence, it means evolution of gas bubble. That is effervescence. Then Jamb will give you another essay. Dilute HCl was added to blah 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 blah. Then a colorless gas with a pungent smell evolves. The gas turns blue litmus paper red and turns acidified potassium permanganate from purple to colorless with no yellow deposit. What gas is detected? The gas is simply sulfur oxide gas, and the ions present will be SO3 2-. Anytime the gas like CO2 is suspected, the ions present will be CO3 2-. When the gas SO2 is suspected, the anion present will be SO3 2-. Then you hear another essay. Dilute HCl was added to this. Then there was evolution of colorless gas with rotten egg smell. The gas turns blue litmus paper red and lead ethanol paper black. Immediately you hear rotten egg smell. Then hydrogen sulfide gas should come to your mind. It is all these keywords you should look at. Turns lime water milky, rotten egg smell, that is H2S, the gas present. And the anion present is simply S2 minus, sulfur ion. These are the hot cake tests for anions using dilute HCl. Now, using conc H2SO4, you are told that conc H2SO4 was added to this and heated. There was evolution of colorless gas with an irritating smell. Now, you see that keyword, irritating smell. The gas turns blue litmus paper red and it fumes in moist air. The gas forms dense white film with the lid of conc ammonia bottle. Which gas is present and which ion is present? Immediately you see irritating smell, know that we are talking of HCl gas, not hydrochloric acid, but hydrogen chloride. In gaseous state, HCl is hydrogen chloride. But if you see HCl aqueous, AQ, that is hydrochloric acid. In this case, the gas present is HCl and the ion present in HCl is Cl minus, chloride ion. Then you'll be told that conc H2SO4 plus manganese oxide plus heat was added to blah 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 blah. Now this is the observation. There's a liberation of greenish yellow gas with a pungent smell. Now you see the keyword, pungent smell, like that of jig, that is like that of bleach. This turns litmus paper red and bleaches it. It turns starch iodide paper blue black. What is present? That is simply chlorine gas, and the ion present is also chloride ion or chlorine ion. Then you'll be told conc H2SO4 plus copper tonics plus heat was added to blah 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 blah, or conc H2SO4 was added, then copper tonics, then heat, whatever. But when you hear the observation, the evolution of reddish brown gas with a pungent smell. The gas turns blue litmus red and starch iodide paper brown. Now look at this. For the first one, greenish yellow. For the second one, reddish brown. Greenish yellow is chlorine gas. Reddish brown is NO2, nitrogen 4 oxide gas. And the ion present is NO3 2 minus. When you see NO2, the ion present will be NO3 minus. When you see CO2, ion present is CO3 2 minus. When you see SO2, ion present is SO3 2 minus. So, ladies and gentlemen, let's look at confirmatory test for anions. When you have a test solution, you add aqueous silver nitrate. Then you add dilute HNO3. Then you add aqueous ammonia in excess. Then you get the following observation. You notice that it forms white precipitate with silver nitrate. Then this precipitate is insoluble in dilute HNO3. And you see that this precipitate dissolves in excess aqueous ammonia. What do you think is present? The inference are 1. When you add silver nitrate to a solution and white precipitate is formed, CO3 2 minus or Cl minus or SO2 minus are suspected. By the time it doesn't dissolve, then Cl2 minus is present. If you now add excess aqueous ammonia and the precipitate dissolves in excess, therefore Cl minus is confirmed. This is confirmatory test for Cl minus. Now, if you have a solution, you add barium chloride aqueous and then you add dilute HCl. If at the point of adding barium chloride to a solution, white precipitate is formed, the following are the inference. SO4 2 minus SO3 2 minus, S2 minus, CO3 2 minus are all suspected. If you add dilute HCl, if this precipitate is insoluble in excess dilute HCl, then SO4 2 minus is present. If it is soluble in excess dilute HCl, then SO3 2 minus is present. And let's look at the brown ring test. Brown ring test is simply adding to the test solution freshly prepared FeSO4 and conc H2SO4. Carefully pour down the size of a filtered test tube. If you do this and you discover that a brown ring is formed at the junction between the two layers of the liquid, then NO3 is present. This is brown ring test. In brand new test, the FeSO4 must be freshly prepared to avoid oxidation. And the brown ring is as a result of the presence of FeSO4.NO. This is what forms the brown ring. Ladies and gentlemen, test for cations, test for anions, and test for gases. This brings us to the end of this episode. Ladies and gentlemen, get the Flashlearners Jamb application. It is compulsory and it is going to help you like never before. Now begin to play with questions. See ya.